In this part 2 of the multiplayer basics in Unity tutorial series, we will read player input and synchronize movement and animations between clients. In a single-player game, all the gameplay logic runs on the same machine. In a multiplayer game, we usually have a server running the game logic and clients messaging it. In a Unity scene, we can visualize the ownership, and the server owns in a multiplayer game most of the elements, so the trees, rocks, tools, and other elements that are connected to the gameplay. When a client wants to interact with a tool, it needs to send a message to the server asking if this interaction is valid and receive a response. This solution allows us to prevent cheating and keep the game fair. The downside of server authority is the delay between the client sending the message, the server processing it, and responding to each client connected to our game so that they can update their game state based on the state on the server. PlayerAvatar is an exception to this rule because it is owned by the client who joins the server, and that is because this client provides the input for the character to move. Now, it is important to realize that when a client joins a session and there are multiple clients in the server, the game session or the game instance on the client's computer reproduces the same player object with the same scripts on it for both clients. So obviously, we need to ensure that player 0 provides input only for its object and player 1 provides input for its player object. That is why in our scripts we are inheriting from NetworkBehavior, because it allows us to check if we are an owner by checking is owner bool flag, or if the script runs on the server by checking is server bool flag. To understand this better, let's create a new script that will read player input. In our project, let's go to the _scripts folder, let's right click, create a new C# script. I'm going to call this my player input. And let's open it up. While not all the scripts will be a NetworkBehavior, in this case we want to have the myPlayerInput inherit from NetworkBehavior, and this is because we are going to need to check if this runs on the client or on the server. Next, we will use the input system package, and we are going to add a serialized field private input action reference m_movement reference, because we are going to access it from the input action map that is defined in every new Unity 6 project. We are going to save the value that we read from it in a public vector2 movement input property with a public getter so that every script can read it, and a private setter so that we can only set it, so only the myPlayerInput can set this value. Now we are going to also have in our game pickup and interact input, so we are going to define public event action using the system library, and we are going to define on pickup pressed and on interact pressed, so those will send us those two additional actions that we are going to implement later. To get the smooth input like we would get with the input.getAxis in the old versions of Unity, we need to smooth it manually. This is important only for the keyboard input, so when we press W or up arrow or any other arrow, it will smoothly go from 0 to 1. And for that we are going to have a private vector2 m_raw input variable and serialized field private float m_smooth time equals 0.1f, so that we can adjust the smoothing. Our logic will be present in the update method, since the NetworkBehavior inherits from the monoBehavior. So we can use the update as we would in a single player game, and if we were in a single player game we would just type m_raw input equals m_movement reference.action.read value vector2, so that we can read the input from the horizontal and vertical axis. And next we are going to assign the movement input property equals vector2, and to smooth it we are going to apply move towards method, and here we are going to just pass the movement inputs of the current value, the m_raw input, so the destination value, so what we want to achieve, and the smoothing will be just time.delta time divided by m_smooth time, and this is how we are going to get this smooth transition from 0 to 1. And again, this is only valid for the keyboard input, but I don't want to add complexity to this script. To get the remaining two inputs, so the pickup input and interact input, we are going to just type if keyboard.current.eKey was pressed this frame, and we are going to have the on pickup pressed (invoke). This is how we invoke event action. And for the interaction, we are going to check if mouse.current.left button was pressed this frame. We are going to call onInteract pressed (invoke), but we are going to use them in the following video. If you ever get lost typing those scripts, I have left a link to a GitHub repository where you can just select a branch. Here is video 1, and you will get a scripts for video 1. We have created Game Manager, and verify the scripts that I have created with your own. Right now, this input will be read and provided for every instance of the player object, even for those spawned by other clients joining our game. So to ensure that this code only runs for the specific game object owned by this client, we need to add if isOwner, and this will check if this is the owner of this object. If this is false, so if it is not the owner, we are going to return and not run this logic. Checking those bool flags isServer, isOwner, isHost is very important, and you need to always remember about it when writing your scripts for a multiplayer game. Let's save the script, let's go back to Unity. In our project, let's go to _network prefabs folder, let's find our player object, and here we just want to add my player input, and this should be it. We need to assign the movement reference, so let's type move. Now this is from the action map provided with every new Unity 6 project. It is already there, so we are just assigning the movement input, so WASD and arrow keys for the player object. Now I can see that I forgot to remove some scripts from those order prefabs, sorry about that, but we are going to adjust them when we get to them. We already have our agent movement script that is using the character controller to make our player object move. Now to send the input from the myPlayerInput script to the agent mover and to make our player move, we need to have another script. So let's create a new model behavior. Let's call it PlayerController. And let's open it up. This script will control the flow of information, although it will probably grow a bit beyond that, having multiple responsibilities at the end of this tutorial. But to keep things simple, we are going to have it as a main manager of a player object. Let's make it inherit from NetworkBehavior. As always, we want to be able to check if this runs on an owner or on a server, and later to communicate with a server. For now, let's delete the start and update methods. And first of all, we need to create two serialized fields. So we are going to create a serialized field private myPlayerInput m_playerInput and serialized field private agent mover m_agent mover. We will need to add update method, and we are going to check if isOwner equals false. We are going to return. This is again because we do not want this script to run if this is not an owner of this game object. Now, when we have that, we are going to type vector2 movement input equals m_player input.movement input. Next, we are going to just call m_agent mover.move, passing the movement input. While you might say that this isOwner check is redundant because the player input already does that check in its own update method, in a multiplayer game it is often very hard to find and discover and fix bugs, so it is very good idea to safeguard from any possible bugs by adding those checks anyhow. Let's save this script, let's go back to Unity. Let's again find the player prefab, let's open it, and we are going to add here the player controller component, and let's assign the player input and the agent mover as references. We can exit the prefab and try testing by pressing play. We should be able to start the host. Remember to start the host first and start the client. But when we try moving, you will see that the movement is not synchronized, although if you try walking into the stone, you can already see that we have a collision detection working in each instance of the game for each player character. Before we tackle the synchronization problem, let's take a look at the player object. It has the character controller, which means that each client performs collision detection on its own machine for its own player object. If fairness and cheat prevention is more important to you, then you should have the client send the input to the server and the server move and perform collision detection and return the new position to the client. The trade-off of this solution is a latency and small delay between the sending of the input and receiving the updated position. Giving clients the authority to move and animate their characters makes the game feel snappy and responsive to the player who provides the input. There might be a small movement delay between the player moving on its own screen and on the screen of the other clients, but in terms of our game, it is not that important. For our client to synchronize its position, rotation and scale, we want to use the NetworkTransform component. In our project, let's again find the player object, the player prefab, and let's add to it NetworkTransform component. This component allows us to synchronize position, rotation and scale and actually choose which of those will be synchronized. For example, I don't want to synchronize scale, so I can uncheck it, and I don't want to synchronize the position, the rotation on X and Z because I know that we are not going to rotate on those axes. Doing so lowers the amount of data that we need to exchange between the server and the other clients, which optimizes our game and usually also the cost of running a multiplayer game. Another important setting that we need to change is the authority mode. Since we are using the owner authority and letting the player move the character, we want the NetworkTransform to synchronize the position from the client's machine onto the server, and the server will propagate it to other clients. Feel free to read more about other settings in the documentation, but what I want to explain as well is the interpolate setting. The problem is that even if our script implements smooth movement, on the screen of client 2, the movement of client's 1 player looks a bit jagged. It looks like it is teleporting because that's what happens. The transform of the object is being updated through the network. If we move the player 2 or client 2 clients to object, it again looks a bit jagged. It looks like we are teleporting on the screen of client 1. The effect might be even worse if we are testing it over the network or the connection is unstable. That's what the NetworkTransform interpolate option does. If we change the position interpolation to lerp and the rotation interpolation to lerp, the result should be that the movement appears smooth on the screen of each client, but there is a trade-off because it might add a bit of a delay between the object owned by the client reaching its final position on the screens of other clients, so there might be a small delay. While the NetworkTransform will synchronize the position, rotation and scale, we also need to add a NetworkAnimator to synchronize the animation component. In our project, we need to open the player prefab and select the child object that contains the mesh of the character and the animator component. What we need to do is add to it a NetworkAnimator. And again, we need to set the authority mode to be the owner because we want the owner of this object to specify what animation should be played, and we need to assign the animator. And basically that is it. It will automatically synchronize the state of the animator. It would look a bit different if we had the server authority and server playing the animation, but again, it would add a delay and the movement would not look so snappy on the screen of the client who owns this object. So that's why often we want the animator to be controlled by the owner of the player object. Let's exit the prefab, and this should be it. We can now test our setup. Before we test, make sure to check the game manager script. I think I have made a mistake here by typing disable buttons instead of enable buttons in the disconnect client method. So make sure to adjust it, save the script, and only then run your game. When you're ready, press play, start a host in the game view of the editor, and start client in the player 2 game view. If you try moving, you should see that the position, rotation, and the animations are all synchronized between both Windows and all the other clients that would join our game. We can try the Player 2 game window, and we can see that the same happens. We can see that the player is animated, it is moving smoothly, and the movement is reproduced, and the animations are reproduced between both windows. And we can even see that the collision detection still works, although again it is handled by the machine of each client separately. Now if we select the Player 2 client window and disconnect and start, not host the client, you will see that the position of the Player 1, so the client's 1 object, is still reproduced, it is kept. So if we disconnect and again connect, it stays at the same position, it does not get reset, so everything is synchronized even for a late joining client. In the next video, I will explain how we can run our game logic on the server by letting the players pick up the axe and pickaxe tools from the ground. Please like the video, subscribe to the channel, and I will see you in the next video.